Welcome to part 1 of Competency 12. In this competency, the teacher understands how to use graphical and numerical techniques to explore data, characterize patterns, and describe departures from patterns. This competency is part of Domain 4, which is 16% of your test. In this video, we will work with modeling data. Be aware of the 6 major types of graphs that you are responsible for: the line graph, the pie graph, stem and leaf, bar graph, box plot, dot plot. In our videos, we focus primarily on some more than others. This is because the students are tested heavier on some rather than others. For example, the pie graph is in relation to percents. So naturally, you'll see it in percentages more often. The box plot or box and whisker is in relation to measures of central tendency. So you'll have a heavy connection and see it in other videos for us. And then the the dot plot is also in relations to your data, which is your measures of central tendency. So it is very heavy. Less popular for testing purposes for your cert would be your stem leaf. However, who knows? It could become heavier tested, but that's in relation to the sciences and that type of data entry. Now, your line graph is connected to your regression, although for the one, and you see the image here, that's data entry. So that is a different situation. Okay. Then your bar graph also can be connected to your histogram. Not as often seen, but still important, and you are responsible for all of its properties. Number 1. Below is a monthly budget of expenses given by category and percent. Which pie chart below represents the information given in the table if an individual earned a monthly net income of $5,500? Okay, let's take a look at what our percents are first. Okay, and these pie charts are obviously pretty big, so we're going to have to look at them individually. Okay, so this is what I need you to see. All right, if we take and put in our calculator, let's say first, well, let's just look at 4%. Okay, what I need you to see is be careful. Okay, I see 4% here, but this doesn't say 4%. And next, with miscellaneous, I see 5.3 here. So obviously, A is not appropriate. It's just like the lost, let's call it a loss leader. Let's call it the guy that doesn't make sense. Whenever you're looking at a test, you're always going to have one of the answers. Well, not always, but high amount of the time, one of the answers doesn't make sense. Well, A is one of those answers that simply doesn't make sense. Okay, but before we look at the others, which are on the next page, let's take a look at what the values are. And the one that I want to focus on here is rent. What is rent dollar wise? Okay, so what are we going to do here? Well, obviously, this rent is wrong. That percent is. We need 24. That's why I'm saying A, the first one that we see, it's just everything is incorrect within it, pretty much, for the most part. Okay, so obviously they have the wrong percent. We need 24%. And something tells me that the dollar amount they have here is incorrect. So what we need to do is see what that dollar amount is actually supposed to be. So I have 24 second percent. And remember, if you've watched other videos with me, you are telling the calculator you want 24 to be a percent. Okay, it's a time saver. Now we need times 5500. which is the given income. Now push enter. So that's supposed to be $1,320, okay? So as we go through, first we need to make sure we're matching the percent, that it's correct uh, on each of these pie charts, as well as the dollar amounts. So everything is just wrong with A, okay? And I wouldn't calculate too many of these until you see what you're dealing on the next page, okay? All right, so let's take a look. Let's go down. Okay. So, ooh, this one's correct. Okay, the rent is correct. Oh, this one's incorrect. Look, that's not, that's $20 less than what it should be. And let's check some of these other percents. That should be 16, I believe, for food. Okay, so we know that's incorrect. Okay. Okay, so 16, oh, actually not even for food. Food should be 15. That's 15.1. Oh, so look, this one says 16 for food. No, everything about that's incorrect. That should be 15. So we're looking at the individual items and seeing that this is incorrect, but some of these others are incorrect. Okay, so let's keep going. Okay. You have to forgive my computer. It's a little slow today. Okay, so let's see here. Yes, I agree with this one. And it's supposed to be 15% here for food. Well, let's randomly check a couple of these and make sure that they're going to be copacetic. First off, all of the percentages are even like what we're given. Okay, we didn't have any decimals like these others, like here for C. C, no, that's not correct. That's not correct. Okay, so we've kind of scanned through that. Now, let's keep looking here. Let's look at food. 15 second percent times the 5500. Yes, that's correct. Let's check here for clothing and double checking your table. Yes, clothing is supposed to be 9%. So 9 second percent times 5500 and $495. Yes. So D is the appropriate representation of our table. Okay. All right. Now let's go on to the next one. Number 2. Given the pie chart below, what is the closest value of the individual's monthly income if the individual's rent is $1,500 per month? Okay, well, what we need to do is for find the percent for the rent and understand that it would look like this. It would be 4.3% times, I don't know how much your rent is. Okay, just make it a little clearer. And it should equal whatever we have for a monthly income, multiply it times our percent, and we should get the 1500. Okay, putting that in our calculator, well, just perform a little bit of algebra, right? Divide both sides by the 423%. Okay, 42.3%. So this means this equals 1. So what are we going to put in the calculator? What I have highlighted. Okay, so let's set up our fraction. 1500, go down, and that is 42.3 second percent. Push enter, and there's always a little bit of an error. So you look at your A, B, C, D options, and it looks like they're going to round up a dollar amount for us. Okay. All right. Let's go on to number 3. All right. Using the information from question 2, what is the cost of the individual's cell phone and plan to the nearest dollar amount? Okay. Well, there's our percent for that. So all we need to do is just simply calculate it. Okay, we can take what's in the calculator or round it up. Well, let's kind of see what it's going to be, what kind of error we get. So we have the amount in our calculator, and all we have to do is say times 5.6 and second percent and push enter. Okay. Well, with rounding, it says to the nearest dollar, round it correctly, and you should see C is obviously the value that we need. All right, let's go to number 4. Number 4, the table shows the population of San Antonio, Texas from 1995 to 2020. Okay. And we can see that the values are in millions and they're telling us that it's real stats. And it is. Which of the following is the best representation of the data? All right, let me move up just a little bit here. Okay, so we can kind of see what we're getting ourselves into. Okay, I'm looking at the pie chart in B. There is no way. That just doesn't tell us anything. I would simply not put a pie chart out there like that, giving me the dates without telling me what the dates are. That is our option that makes no sense. So that's not going to work. Okay, now we're between A and C. Okay, fine. I need you to look very, very closely at your scaling. That's like always the first thing that you need to look at and will be asked. You know what? Come to think of it, on testing, there are some properties of scaling. It would be for the middle school, but not necessarily for the high school. So for anyone taking this particular middle school TExES, if that's what you are actually going to take, please be careful and read everything. Okay. So take a look at the numbers and the way they're represented. Okay. And you can see each of these tables gives you an estimate of what they are. Okay. However, with the line chart, yes, you see, okay, it's a little bit clear. But then on the other hand, you could argue for the bar chart. Okay. It's not a histogram exactly, but it is a bar table or chart, however you want to say it. Okay, yeah, I could estimate with both of them, but there's a big thing I want you to look at. Your years are here. Absolutely, I agree with that. They match your table. What is not okay is right here. Okay, they don't exactly tell you what you're looking at. Like they don't say this is people in whatever, whatever. For C, it's the numbers themselves. Okay. Right. Look, it tries to get you to estimate the in millions, is what I'm trying to say. Okay. However, A, look at this little issue. This just doesn't work. It is a completely misscaled representation. Therefore, A, in no way, shape, or form, sorry about that. I shouldn't have circled that. I should have X that. It's just not going to work. It does not properly represent the information given, even though we are estimating in our given charts or graphs. The table gives us a more exact value. Okay. But we're not going to get that with these, but you need to have a good, best representation. And billions is not going to be close at all. That's not how many people are in San Antonio. Okay. All right. So let's move on to the next item. Number 5. Which of the following box plots represents a particular set of test scores stated below? Okay, we're looking at a minimum of 70 and a maximum of 94. Okay, well, let's check those first. Okay, I agree here. A and B and C and D. So the minimum isn't going to help us. Okay, they're saying the maximum the end of the whisker would be 94. Okay, I'm okay with this one. Okay, check mark on that. Check mark. Oh, I do not agree with this one. So I'm going to say no to D. And I do agree with this one. That's okay. So we've eliminated one of our box plots or box whisker, however you want to say, whatever you want to call them. Okay, now, first quartile, which is Q1, is at located at 74. Okay, A, I would agree with that. C, I would agree with it. And B, sure. Okay, so let's move on to Q3 or the third quartile. That would be the other end of the box. They're saying 92. Okay. Yeah, estimating. Okay, I'll buy it. Yeah, I'll go for that. And this one, yes. And this one. Okay, well, those all check out. That's not helping me. What about your median of 82? That is your Q2, which is this line right here. For this one, it says 80. I do not agree with that median or Q2. Okay, so A has been eliminated. Okay, B, I would keep it because I could estimate that same. Okay, I believe it's 82. Good enough. Oh, but let's look at C. That looks more like 84-ish. Nope, that eliminates C. What does that leave us with? That leaves us with B, actually. Okay. All right, let's move on to number 6. Okay. And it says, using the information from question 5, well, that's above, what is the IQR of the given data? Okay. That is the interquartile range. That's what IQR stands for. If you don't know this or don't remember, what that means is that you are going to figure out what is the distance of one end of your purple box to the other end of the purple box, okay? So it's Q3 minus Q1, okay? Because remember we had Q1, Q2, and Q3. So looks like we have 92 minus 74. Yes, 74. Okay. And that is 18, which for us, that would be option A. Okay. And as I said prior, in the video, if you were not familiar with or you do not remember the properties of each of those charts or tables, any of those items, please make sure that you're familiar with those. Okay, let's move on to number 7. Number 7, select the stem and leaf plot that represents the data below. Okay, you may be just about to panic looking at all those numbers. The key here is I'm looking at it and I'm quickly seeing some facts. If you know the properties of a stem and leaf, you automatically should know, just get rid of one immediately, which is C. This is simply not a property of your stem and leaf. So that is been eliminated, just eliminated. Now, I'm looking at another one. Let me go up. I'm looking at D. I don't like D. This is not how we represent 50. Okay? This right here. It's just empty, and that's just not acceptable at all. Okay? It's just not how we do things. And even down here, we're separating them out. This is an inappropriate stem leaf representation. Okay, so that eliminates D. Okay, so now let's go back up. looking at your values as well as our A and B that are left for us, okay? All right, so I'm going to look at my first line. They're the same. I'm trying to find differences. So this and this are the same. Now go to your 6, which would be any values of 60, like 61, 62, your 10s and the 6, okay? All right, I'm seeing right here this difference and this difference. Okay, that's a pretty significant difference. What it's saying is A says you have one value of 60 in your list. B is saying you have no values of 60 in your list. So I'm going through and I'm looking very quickly and I see a value of 60. And that automatically eliminates B. And then you can go through if you wish and check all of these, which I have done. Make sure you find a 70 somewhere. And there it is. Okay. Your eyeballs start getting crossed, but if you go through and find each of these, you will find it. And of course, it should be there because it's on the other one regardless. So, option A is it checks out for each of these. You can go through them in your own time, but I wouldn't waste my time on a test with these. The minute I found what you could call a counter example or a non example with your other options, get rid of it and move on. All right, let's go to number 8. Number 8, the company recorded the sales in dollars of two store locations. The box plots below show the results. Okay, so you have location A is first, then location B. Which statement is best supported by the information in the box plots? So in this case, we just read them one by one. If we have to use our calculator to prove or disprove, that's what we need to do. So let's look at number A or option A. The interquartile range of location A sales is twice the interquartile range of location B. Well, the first thing that we need to note is that everything involved as visually is A is less than B. And let's look at the interquartile range. Okay, this is this, which is IQR. Okay, we talked about that earlier. Okay, we can see that actually B is twice than A, or we could say A is half of B. Well, option A states it backwards, so that's not okay. All right, so B. The mean of location A sales is $5 less than the mean of location B sales. Well, value wise, how are you going to get that? Mean is not a property that we really discuss with box plots. And if you can discuss them, okay, you can't put a dollar value on it without having a list of the information, a very precise list. So, that being said, B would be our option that just doesn't make sense in this situation. Okay, if we had a table of data, sure, then we could, but right now we can't. So that's not okay. Now, some of you might say, well, wait a minute, if we had, we looked at skewed, well, they're both skewed the same direction. Okay, well, you can't look at skewed because when they're skewed the same direction, that means their mean value would be in the same location greater. So we still don't have that mean. We just can't do it. I don't care how you look at it, it simply won't work out for us. All right, so let's look at C. The interquartile range of A sales is half the interquartile range of B sales. That we can agree with. We've already stated that. I'm going to go with it. Now let's look at D real quick. The range of A sales is $10 more than the range of B sales. Well, I really dislike that they're saying A is more than B. That is just not true. The range of B is obviously greater than A. Okay, and it might be 10, but they're stating it the wrong way. They're trying to trip you up. Okay, so let's look at A. A is 125. That's right here. See, it's right here. Okay, minus 70 right here. Okay, that's 55. All right. Okay, here. Oh, it's kind of messy. Okay, so now what we need for B is 30. We're saying 30 minus 65. 130, that is. 130 minus 65. Okay, yeah, there is a difference of $10, but B is $10 greater than A. Okay, so we know option D is incorrect. All right, so let's look at number 9. Okay. Two rescue shelters measure the weight of puppies in their care. The dot plots display data from each shelter. So we have shelter 1, shelter 2, and then it's puppy weights in ounces. Okay, and looks like some of them are over a pound. Ooh, that's a pretty big puppy. Okay, so let's look at what it says. It says, which statement is best supported by the information in the dot plots? Okay, so we do the same thing. The two shelters, this is A, the two shelters have different mode weights, where mode is the weights that we would see the most. So it would be the highest. Well, here and here just so happens those are both 15. So they're equal. Yeah, they are not different, so that's not true. B, the two shelters have different median weights. Oh, okay, we can see right away that that's not true either. Median weights are the middle. You go to the very middle of your data. Well, our middle would be also somewhere in here with 15 and somewhere here. You just count to the center from each end. So you can tell where it's going to be. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, somewhere around 12. Let's count the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, I've got it circled. I kind of guessed there. So now that you saw how I counted to the middle from each end, so I counted the left to the center and the right to the center. Well, if you do the same thing with shelter 2, you'll have 15 again. So that's not helping. Okay, so let's look at C. The data of the two shelters have different skews. Ugh. Well, they're not either one. They're not skewed to the left or skewed to the right. They're kind of symmetric. Oh, not kind of. They are symmetric. So, that being said, they don't have different skews. They're both symmetric. So, I disagree with that. No, cross our fingers. We're left with D. The data of the two shelters have different ranges? Okay, I'll believe that once I calculate them. So let's do that. Let's look at shelter 1. I have 18 minus 12. What do we have? 6. Okay. And then over here we have 19 minus 11. 19 minus 11. And it's 8. So they are different. So yes, we are left with option D. Wonderful. Okay, this is the last question in this particular video. Again, I will have more videos coming. I want to thank you for watching and subscribing and sharing. Sharing's the best. For those of you who have shared and have also been to our website at numbersareradical.com. Thank you very much. And some of you have bought materials, and right now we are working on, that's why this video is coming right now. I am working on Competency 12 for the 4 to 8 math test TExES exam. And as soon as I get all of the competency finished, I will post it. So if you haven't joined us at numbersareradical.com, you might want to go check out what we have thus far. Happy testing, everybody.